So the first thing we want to do here is we want to factor this. There's that negative 1/2 coefficient as our horizontal compression factor, or in this case, expansion factor. So I'm going to write this as 3 sine, and factoring out that negative 1/2, I end up with theta plus pi over 3. Now we can check that that actually works. We could just multiply that out. Yeah, we generate the negative pi over 6. So we've done that correctly. And then minus 1. So starting with our vertical shift is going to be negative 1. Our phase shift now, since it's in factored form, our phase shift now is much easier to identify. Our phase shift is negative pi over 3. The period is going to be based on this term here. It's going to be based on that expansion factor. So we're going to divide by 2 pi divided by 1/2. It's going to give me 4 pi. So there's our period factor. And then lastly, the amplitude. We can get the amplitude from this term here. I'll just do it like that. The amplitude is 3. So we're going to use that for our amplitude. Okay, so we can start sketching in our guidelines here. So we're going to start with negative 1. Make sure that we can accommodate an amplitude of 3. So I'm going to just draw it right about there. There's my vertical shift of negative 1. My phase shift is negative to the left, pi over 3. But remember that there's a horizontal flip. So we're going to end up drawing the graph in this direction. Okay, so that horizontal flip is going to be in that direction. So when I sketch in my graph, I'm going to first of all identify my x-axis here. Okay, and then see how many pi, I need to fit in 4 pi in here. So I've shifted. So let's say that's negative pi, negative 2 pi, negative 3 pi, negative 4 pi, maybe about here. And we actually need to go a little bit further to be able to fit in that horizontal shift to the left. So here's my horizontal shift, my phase shift. If this is going to be negative pi over 2, so negative pi over 3 is right about here. Okay, and I'm just going to draw it so I can fit in my amplitude of 3. So this is going to be negative pi over 3 shift. My end position, I've got to add or subtract in this case 4 pi. So I'm going to end up at negative 13 pi over 3. So right about here. And I got that by starting at negative pi over 3, or negative 1/3, and subtracting 12/3. So that's negative 13 pi over 3 is the ending position. Okay, so then I want to draw in my middle line. And I can work out the position of that middle line by adding negative 13 plus negative 1. That's negative 14 divided by 2. That's going to give me negative 7 pi over 3. Getting the next quadrant, okay, I'm going to just kind of eyeball it for now, but then I can still calculate this. It's going to be halfway between the start of negative 1/3 and negative 7/3. So that's going to be negative 8/3. I add and divide by 2. That gives me negative 4 pi over 3. And then I have my other quadrant here. And I add negative 13 plus negative 7. This is negative 20 divided by 2 gives me negative 10 pi over 3. Okay, so finding those coordinates, the location of those quadrant boundaries is, I find, is much easier if we use that middle formula. Okay, so the amplitude is 3. So I'm going to start, it's a sine graph, so it starts in the middle, and I'm going to draw it to the left. Okay, so it's going to go 1, 2 to positive 2. This graph's going to go -1, -2, -3, down to -4. So my amplitude is going to bring it down to -4 and up to positive 2. So drawing this in, starts at the middle. I'm going to the left since it's a horizontal flip. It's drawn there, back to the middle, down to the bottom, back to the middle. And then I can draw in my quadrants, my 4-part symmetry. And so then I've got my graph. Now notice I've drawn it as a horizontal flip this way. Now, if you don't like to draw it to the left, a horizontal flip, we could have actually drawn this as a vertical flip. So instead of drawing it as a horizontal flip, we could have actually drawn the coordinates down. So it could have gone down, back up, and we could actually draw this to the right in this direction. And this would have been drawn as a vertical flip. And those vertical flip and the horizontal flip really are the same graph. And again, there is an identity that relates that. I do need to calculate, write in the coordinates of the min and max, so -pi/3 and +2. This is -10pi/3 and -4. That represents my min and max points. So lastly, give the decimal values for the zeros. So I'm going to do this on a separate video, and I will show you how we can do this. So actually, I'll do this without the algebraic, using an algebraic strategy. I'm just going to graph it. So when I graph it, I can solve for my zeros here and somewhere around here. And off the graph, I'm getting -6.65 radians. Okay. Write that in a little bit neater. So -6.65, and the other zero here, that's -1.73 radians. Okay, so those represents 2 zeros, one theta 1, one theta 2. We always have to remember about theta 1, theta 2 in one period of a solution. Okay, so we have 2 different solutions, theta 1 and theta 2, in one period of this graph.